Hi friends, in last session we have seen the introduction to the influence coefficient. Now we are going to solve one numerical on the flexibility influence coefficient. In last video I have explained you the two types of influence coefficient. The first one is the influence coefficient itself, it is the flexibility influence coefficient. And the second one is the stiffness influence coefficient. Now how to solve this problem? To solve this problem it is very much easy. Now first, before going to this numerical, again one more time we'll see what is the influence coefficient. So influence coefficient, it is represented by Aij. Okay, what is meant by this Ai and what is meant by this J? Now Ai means deflection at point I. Deflection at point I due to unit load at J. So if you know this term, that is we'll have to determine the deflection because of the unit load at J, then it is a very simple problem to solve. Now I am going to use this one. Now to solve the problem, see, we will have to consider the unit load. So somewhere we have to consider the unit load. So we, in the problem, if you see, the three masses are given, and we call the first mass as mass 1, second as mass 2, and third as mass 3. So we'll have to apply the unit load at each mass. So for first condition, we'll consider. So for first condition, we'll consider the unit mass. Now first we'll consider unit force at mass 1. So consider unit force at mass 1, means force value at mass 1 that I am going to consider is 1. So the force at 2 will be 0 and force at 3 will be 0. So in first condition, what we have considered? We have considered that it is the force at 1 is 1 and force at 2 and 3 is 0, because we will have to apply unit load. Unit load means unit force at any one mass. So we have considered for first mass. Now they have asked to find the flexibility influence coefficient. So that influence coefficient matrix will be A11, A12, A13, then A21, A22, A23, A31, A32 and A33. So this is the influence coefficient matrix. Now after considering unit load at any one mass, then draw the FBD. So to draw the FBD, we have total 3 masses. So I'll draw the 3 blocks of 3 masses and will show the forces acting here. So how to show the force? The spring force is always opposite to displacement, the first thing. Then we show the inertia force, but instead of inertia force we have already considered the forces on these masses. So here for mass 1, the deflection in the right side, so I'll consider here the force 1, that will be equal to 1, then force 2, that will be equal to 0, then force 3, that will be equal to 0. Okay, so I have shown the forces which we have considered. Now I'll show the displacement. The first displacement is x1, the second displacement is x2, third displacement is x3. Now whatever I am writing here, it is very much important. Now see how to write this in terms of influence coefficient. See, for this condition we have considered the load at 1, means here the value of J is 1. In Aij the value of J is 1 because we have considered the force 1. Now we'll have to determine deflection at 1, deflection at 2, deflection at 3. So according to that, I'll write here A11. Why this is A11? Because we are determining the deflection at 1 means x1 because of unit load at 1. See here, unit load at 1. Similarly, here what we can write? Deflection at 2 due to unit load at 1, because we will determine the deflection x2 and we have provided the load at 1. Similarly, here what we can write? A31, that is deflection at 3 due to load at 1. Okay, so x1 will be A11, x2 will be A21 and x3 will be A31. And if you carefully see from the matrix, then just see this vertical. The first member is A11, which is here. The second member A21, which is here. And the third member is A31, which is here. So we can directly take this A11, A21, A31 value, or instead x1 is nothing but deflection at 1 due to load at 1. A2 means deflection at 2 and 1 means load at 1. So we can write, or we can directly take from this influence matrix. Okay, now after showing the force, after showing the displacement, now we'll have to show the spring forces. See the first spring force. See, this spring will be elongated, so x1 will move this mass on right side, so ultimately the spring force will be on the left side. And what will be the spring force? Spring stiffness, spring force is K into X. Spring force is K into X. So K means stiffness. So what is the stiffness? They have given, just check, the stiffness is 3K. So stiffness into its displacement, and its displacement is here, just see x1, and x1 is nothing but A11. So KA11. Okay, now for the second case, see in earlier videos we have seen this FBD. If x2 is greater than x1, means this spring is going to elongate. So I will show here. Suppose this is the spring, and if this spring gets elongated because of x2 is greater than x1, then this is the displacement. Then how to show the force? The force will be, spring force will be opposite. So this will be the force. Okay, so we will have to show this force here. Okay, so this force will be on this direction, this will be on this direction. Similarly, if I consider x3 is greater than x2, again this spring will be elongated, so forces will be in the opposite direction. Now what is the spring force? Spring force is nothing but Kx. So K into, what is the X? X is, just check, x2 minus x1. So here we will have to write A21 minus A11. So K A21 minus A11. Now what will be the force here? The spring stiffness is K. So force will be K into x3, that is A31, minus x2, that is A21. Okay, so this is the spring force. And on this last mass M, we don't have the spring on right side, so I have not written anything here. So this is the FBD. This is the important part in the influence coefficient calculation. And if you draw this FBD, then we will have to repeat the same FBD, but by just changing the force value. Okay, 3 times. So initially we have considered the force at 1. So according to that, I have made this FBD. Now for equilibrium condition. For equilibrium condition. Now what I can write for equilibrium condition? On mass 1, the summation will be equal to 0. So I am going to consider the direction of force as positive. Okay, so from this equation, from this mass, you can write F1, which is on right side, F1, then this force plus K A21 minus A11, then this force minus 3K A11. See, we have considered the force direction as positive, so this right side is positive and left side is negative, and the summation of all will be equal to 0. Okay, so I have written for the first case. Okay, now just put the values. We know f1 is equal to 1, so 1 plus multiply by this k in this bracket, so it will become k into a21 minus k into a11 minus 3k a11 is equal to 0. Now here we have a11 term, okay, so minus k minus 3k, so it will become minus 4k a11 equal to 0. So I'll note this equation as 1. Okay, so whatever I have written here, this is for the mass 1, so I'll mention here for mass 1. Okay, so whatever I have written here is for mass 1. Similarly I'll write for mass 2. So just check for mass 2. Now for mass 2, F2, which is on the right side, just see F2, then this force plus K A31 minus A21, then this force which is on the left side minus K A21 minus A11 will be equal to 0. Okay, now multiply by K inside this bracket. So F2 is nothing but 0. Just see the value of F2, 0 plus KA31 minus KA21 minus KA21 minus minus plus KA11 will be equal to 0. Now just check the common terms. So 0 plus KA31, see here minus KA21 minus KA21, so it will become minus 2KA21 plus KA11 will be equal to 0. Okay, so this will be our equation number 2. Now similarly I'll write here for mass 3. So for mass 3, okay, now write for mass 3, the first force is F3, which is on the right side. After that we have another one force which is on the left side, that is minus K A31 minus A21, that will be equal to 0. So what is the value of F3? It is 0 minus K A31 minus minus plus K A21 will be equal to 0. So just transfer this minus side on the right side. So K A21 will be equal to K A31, this minus will become plus. Now cancel K, so we will get A21 equal to A31. Okay, so this will be the equation number 3. So we have 3 different equations from mass 1, mass 2 and mass 3. Now put this value A21 in equation 2. So I'll write here, put in equation 2. So just put in equation 2. So this equation 2 will become K. See, we know the value of A31 and it is A21. So I'll write, instead of K A31, I'll write K A21 minus 2K A21 plus K A11 will be equal to 0. Now combine this one, minus KA21, sorry, plus KA21 minus 2KA21 means minus 2K plus 1 means minus 1. Minus KA21 plus KA11 equal to 0. Now transfer this side here. So KA11 will be equal to KA21. K will be cancelled. So A11 will be equal to A21. Now just see this equation 4 and equation 3. So A11 is A21 and A21 is A31, means all A11, A21 and A31 all are same. Okay, so put this value in equation 1. So put in equation 1. So equation 1 will become 1 plus KA1, sorry, KA21. So KA21 means A11. Just see K21 is KA11 minus 4KA11 will be equal to 0. So this will become minus 3KA11. This one is remain as it is. Now transfer this term on the right side. So the minus term will become plus. So 1 is equal to 3KA11. So finally we will get the value of A11, and A11 will be 1 divided by 3K. So we have A11, that is the 1 divided by 3K. But from equation 4 and from equation 3 we can write A11 is equal to A21, which is equal to A31, and the A11 answer is 1 by 3K. So we got the 3 influence coefficients: A11, A21, A31. Okay, so from this matrix we got these 3 terms from the column. Okay, and to determine this, what I did here, I have considered the F1 is equal to 1. Now in the second case, what we are going to consider, F1 will be 0 and F2 will be same. Okay, 1. So I am going to repeat. So here I will write, consider F1 is equal to 0 for second case, F2 will be 1 and F3 will be 0. Means in first case F1 was 0, now F2 is 1. Now no need to write again this FBD. I am going to repeat the same FBD, but only I am going to change the force value and displacement value. Okay, so the first mass is 4m. So I will write here 4m, then the second mass, then the third mass. Okay, so second mass is 2m, third mass is m. So it is 2m and this is m. Now show the forces. Now here F1 is equal to 0, F2 is equal to 1, F3 is equal to 0. Now we are going to determine the displacement x1. So what will be the value of x1 here? What will be the value of x1? Just see, we are determining displacement at 1 but unit load at 2. So it will be A12. What will be the value of x2? We are determining the displacement at 2 but we have taken the load at 2. So A22. And what will be the value of x3? We are determining the displacement at 3 but we have taken unit load at 2. So A32. Or directly you can write A12, A22, A32 from this matrix. Okay, actually we are determining this matrix. So just see the column A12, A22, A32. Okay, and these values directly you can put here. Okay, so we have finished with force and displacement. Now just we will have to show that spring forces. So for that, just go to first FBD. Here see 3K displacement. So 3K into A11. So here I am going to replace 3K into A11. Instead of that, I will write the displacement is A12. Now the forces, here the spring will be elongated if x2 is greater than x1, then that spring force will become K x2 minus x1. So x2 is A22 minus x1 is A12. Similarly here I can write stiffness into x is x3 minus x2. So A32 minus A22. Okay, so you can take the reference of this one. Instead of A11 you have to replace A12. Instead of A21 we will have to replace A22, and instead of A31 we will have to replace A32. Okay, then we will get the FBD. So there is no need to again write the FBD. Just copy it and replace the term which you want to replace. Okay, according to the consideration. Now here again we will consider the equilibrium condition and we will write So here consider equilibrium condition, but now I am going to give the most important hint, that by Maxwell's reciprocal theorem, just we will go back here, the value of A12 and value of A21 is same, means Aij is equal to Aji. Okay, so by Maxwell's reciprocal theorem, Aij is equal to Aji, and we already know the value of A21, and that will be equal to A12. So A12 will be equal to A21 will be equal to, what is this value? 1 divided by 3k. So there is no need to determine A12 here, because by Maxwell's reciprocal theorem we know this value. Okay, so this A12 is going to come in mass 1. So here I am not going to write the FBD and its equilibrium condition for mass 1. Instead of directly I will go for the mass 2. Why I am directly going to mass 2? Because we already know by Maxwell's reciprocal theorem the value of A12. So directly go to the second mass. Okay, so write for the second mass F2, which is on right side, then plus K A32 minus A22, then minus K A22 minus A12 will be equal to 0. Now what is the value of F2? It is 1 plus multiply by K in the bracket, K A32 minus K A22 minus K A22 minus plus K A12 will be equal to 0. Now whatever the values we know, you put, and here you can see the same term is repeated, so it will be minus 2k A22 plus k into, we know the value of A12, and A12 is 1 by 3k, so it is 1 by 3k will be equal to 0. So this k will be cancelled with this k, so the equation will become 1 plus k A22 minus 2k A22 plus 1 by 3 will be equal to 0. Now combine 1 and 1 by 3, make the denominator same, so it will become 4 by 3. So k A22 minus 2k A22, sorry, I have made one mistake here. Instead of A32 I have written A22, so this is the A32, sorry, so first term is A32, it will be equal to 0. So mention this equation number 4. Okay, I will check the equation, last equation number. Yes, we have given up to 4, so this will be 5. This will be equation number 5. Okay, so I have written from mass 2. Now write from mass 3. So here I will write from mass 3. Now F3, which is on right side, there is no force here, so minus K A32 minus A22 will be equal to 0. What is the value of F3? It is 0. So minus K A32 minus plus K A22 will be equal to 0. Now transfer this minus side on the other side. So K A22 will be equal to K A32. So KK will be cancelled. So A22 will be equal to A32. Mention this as 6. Now put the value of 6 in 5. So put the value of 6 in 5. Before doing, I will mark this. Okay. Now put 6 in equation 5. So the equation 5 will become, see, 4 by 3 plus K A32. A32 is nothing but A22. So A22 minus 2k A22 will be equal to 0. This term will become minus k A22, 4 by 3 will be equal to 0. So 4 by 3 will be equal to k A22. So transfer this k on the other side. So A22 will become 4 by 3k. But from equation 6, A22 is equal to A32 is equal to 4 by 3k. So finally we got the two values, and initially we got one value by Maxwell's reciprocal theorem. Here we can see A12. Yes, we got all the values A12, A22 and A32. Okay, so we have finished with the second. So we got the second. Now we'll move to the third. Now again we'll determine this third one, that is the A13, A23 and A33. Now how to determine this one? Yes, to determine, again we'll have to go to third consideration. Okay, so the third consideration will be, see, the first consideration was first force is 1. In the second consideration, the second force is 1, and in third consideration, here we will consider F3 is equal to 1. So ultimately F2 and F1 will become 0. Okay, now again we will have to draw the FBD. So I'll quickly draw the FBD. You can directly copy the FBD that we have earlier drawn and just change the value of displacement and force. See, here F1 will be equal to 0, here F2 will be equal to 0, and here F3 will be equal to 1, and here displacement x1 will be equal to, now displacement at 1 because of unit load at 3, so this will be x1 is equal to A13, so x2 will be A23 and x3 will be A33, means displacement at 3 due to unit load at 3. Okay, now the remaining thing I'll keep, see here 4m, 2m, m, so masses are 4m, 2m, m. The first spring force is, just check, 3k A12. So here I can write 3k, and instead of A12 I can write A13, means k into x. Here it will be, if x2 is greater than x1, the spring will be compressed, so we can write k, stiffness is k, into x2 minus x1. x2 is A23 minus x1 is A13. Here I can write k A33 minus A23. Okay, so this will be the spring force. Now we'll use the Maxwell's reciprocal theorem. So Maxwell's reciprocal theorem, and we'll get the sum of the values. Now for that I'll go back to that matrix. In this matrix, see, now we can say A13 will be equal to A31 and A23 will be equal to A32. Okay, because we are determining from the third column, so these two values we will get directly. So I'll write A13 will be equal to A31 and the second A23 will be equal to A32. Now just see the values. Here we have value of A32, it is 4 by 3k. So this value we directly have from the previous calculation, and for this one we'll have to go to the first calculation, A13. So go to the first calculation, and here we have A13 or A31, that is 1 by 3k. So it is 1 by 3k. So we have two values, from mass 1 and from mass 2 we have both the displacements. So there is no need to write FBD, sorry, equilibrium condition for that. So we will directly consider the equilibrium condition for mass 3. So I will write here, consider equilibrium. Now write from the third one. So F3 minus K A33 minus A23 will be equal to 0. So what is the value of F3 is 1 minus K A33 minus plus A23 will be equal to 0. And we know the value of A23. Here just check 4 by 3K. So 1 minus K A33 plus 4 by 3K. So here into K. So K will be get cancelled. Now transfer this term, minus term on the other side. So here it will be remain 1 plus 4 by 3 will be equal to KA33. Now just add. So make the denominator 3 for first term. So it will be 3. So 3 plus 4 is 7. KA33. So A33 will be equal to 7 by 3K. Equal 7 by 3K. See, by Maxwell's reciprocal theorem, we have value of A13, now A23, and now we got A33. Now we got all the answers. So I am going to write the answer here. The influence coefficient matrix, that is A11, A12, A13, A21, A22, A23, A31, A32, A33 will be equal to, just put the values. So first consideration we will get the answers here. A11, A21, A31 all are same and it is 1 by 3K. So 1 by 3K, 1 by 3K, 1 by 3K. So first column is same. Now go to the second one. In the second, just see, A12 is 1 by 3K, A12 is 1 by 3K. So here I will write 1 by 3K. Now A22 and A32, just check, A22 and A32 is 4 by 3K. So here I will write 4 by 3K, 4 by 3K. And for last A11, A13, A23, A13 is 1 by 3K, A23 is 4 by 3K, 1 by 3K, 4 by 3K. So 1 by 3K, 4 by 3K, and the last value here just see 7 by 3K. This is your answer. This is the influence coefficient matrix. Thank you.